In this lesson, we're going to finish up factoring binomials and actually factoring trinomials, and we're going to practice some multiplication. So in the last time we checked, we had some binomials here, and we were going to factor using differences of square. And so I'm going to go ahead and put the answers here. But I think what's important to note is that for this to work, both terms in that binomial have to actually be squared. So we can't have one of the terms or one coefficient that's not squared. They both have to be squared for this to work. It's also really important, especially in the beginning, for you to check your answers. We are still learning, and this is the first time you've seen this in your life. So it's very important to go ahead and follow up and check your answers. I'm going to check one of my answers here with a table method of multiplication. With a table method of multiplication, you just do like you would a multiplication chart and multiply all terms. Combine your like terms that are in the middle. And then what you'll see is that indeed I have the 6 as the exponent and the 25 outside. This method of factoring the difference of squares only works when you are actually subtracting. So that's why it's called difference of squares. And it only works when the other two terms in your binomial are squares. It doesn't work for any other term. Now what we're going to do is we're going to look at what the other terms might look like. And so in order for us to start factoring them, we first need to realize what they would look like if we multiplied them. So our first term here is x plus 3, and I'm going to square x plus 3. When I'm squaring something, I'm basically saying, hey, I have two of these, two of the same, and I want to multiply them together. So in this case, we're going to use the FOIL method to multiply x plus 3 times x plus 3. And my answer is going to be x squared plus 6x plus 9. Now sometimes what you want to square is not a binomial it's being added. Sometimes it has a subtraction sign. So what if you had x minus 3 squared? Well, it's essentially the same. We have two of the same, which is x minus 3, and we're going to multiply them together. And I'm using the FOIL method here to get my final answer, x squared minus 6x plus 9. And so really you may have noticed that the only difference between these two problems that we just did, because they had the same number inside the parentheses, was the addition or the subtraction sign in between. And so you may have noticed that the numbers are going to be the same. It's going to be x squared, it's going to be 6x in the middle, and it's going to be 9 at the end, but the sign is going to change depending on what sign you have inside the parentheses. That's important to note. I'm going to write a couple of problems for you to try to do on your own, and then I'm going to show you how to multiply them together. I'm going to go ahead and get started. So if you haven't done it, please go back and pause the video and try it yourself. We have 2a's plus 6, and then we have 2 5 minus w's. We're going to multiply these binomials together. You may use the table method or the FOIL. I'm going to use the table method for the first one and a table method for the second one, since I've already shown a lot of you how to do the FOIL already. That is my preferred method. I don't really use the table method a lot, but it's important for you to know how to do it with both methods. Your middle terms are going to be combined because they are going to be like terms. We have 6a and 6a. Together they make a 12a. And then for the bottom, you're going to have a negative 5w and a negative 5w. The w is raised to the same exponent, so they are considered like terms. So you're going to combine them, and they're going to give you a negative 10w. And then the ends are going to be squares. Important here to notice, I want you to notice that the B example had a subtraction sign in it. And so that's why we also have a subtraction sign in the final product as well. By now you may have noticed a pattern, and in fact there is a pattern. We have a rule of what we should expect our answer to be when we're multiplying a binomial by itself, when we're raising a binomial to the power of 2. So the rule is, if I am adding these two terms and I'm going to raise it to a power of 2, then my answer is going to be the first term squared plus 2 times the first term times the second term plus the last term squared. I'm going to write it down for you right now. Usually use variables to talk about terms so that it applies to any problem. And so in this case, even though I'm writing A, I could apply it to this problem, and you can see where A might be the A for the first problem and B might refer to the 6. Likewise, we can assign those variables for the second problem as well, and we can see that our first term is going to be a squared, which is 5 squared. Our second term is going to be 2 times ab. If a is 5, then b is w, and so on. Now, the main difference between adding and subtracting is that the sign of the term in the middle is going to change. Your last term is always going to be positive because anytime you square something, whether it's positive or negative, you're going to end up with a positive result.